So hello, my name is Tomáš. I'm architect of Project Helidon at Oracle. And I will be talking today about something new, something that will be available in the future. Hence the safe harbor statement. The things may change. Let's hope that they will not change too much from what I will be showing today. So what I want to do on this presentation, I want to introduce Project Loom and its features. I want to do a quick introduction into what Helidon is, because I will be using it eventually in the demo. And I will present a use case that demonstrates how Loom helps and what are the alternatives to it. After that, I will be showing some code and running the presentation that actually demonstrates how Loom resolves some of the problems we can face when programming. And of course, a few minutes for questions and answers. So let's start with Project Loom. You can find it on java.net. You can download early access builds of Java 18 with Project Loom. And of course, there is a project page with wiki that describes what it's doing. Long story short, the key feature of Project Loom are virtual threads. So what we know from application servers, or we're writing our own applications, we got used to using executor services, thread pools that handle our work. And in general, this is limited. We know that there is a certain amount.
Mr. Langer, sorry that I interrupt. You're not sharing your screen.
Oh my God, this is really, what happened?
Sorry.
I was, okay.
Perfectly,
I'm really sorry
okay.
about this. Let me just quickly jump to my face so you know, hi, that's me. I have gone through this, so let's go to the Loom. All right, so back to the threads. There is a limitation of number of threads you can have. We found out that usually you can reach 400, maybe a bit more threads on a single machine, but eventually you will start having real trouble with context switches. So whenever a new task needs to be executed on a thread, suddenly you will spend more and more time in your system CPU, and you will have less time for your business application. Another problem with threads is that whenever you execute a blocking operation, so let's say you are querying a database, you are writing to a file system, or you are calling another service over HTTP, the thread is blocked. And as long as it is blocked, it's not doing anything. And let's be fair, in most of the enterprise applications, this is happening, and this is happening a lot. And what ends up happening is that you have your 400 threads waiting on something while your CPU is almost idle. And that's not a good utilization of resources. So what is the solution? Everybody knows about reactive programming nowadays, which is one of the ways how to solve the problem. Our engineers at Java looked at that from a different point of view and said, like, we have threads, we need them blocking, and at the same time we want CPU utilization. So let's try to find a way how to decouple the CPU threads that are active, similar to event loop in a reactive, and create something called virtual threads that will be your blocking vehicle, that will be pinned to the actual thread only when it needs to work. So they designed Project Loom and virtual threads, which the feature is you can have millions of them. You can block whenever you need to block, and you do not need to care about the underlying thread. So for example, when you call a database, your virtual thread will be blocked, but the underlying operating system thread will be just unpinned and will be used by another virtual threads. The good thing about threads, virtual threads in Loom, is that they are threads by API. So you use your API that you are used to. You can use thread locals. You can do basically all the operations that you are used to do. The only difference is that suddenly you are not blocking the underlying thread. The API is not that huge. So there is one new method on executors. And that depends on which build you download. If you download the currently available build of Java 18 with Project Loom, there will be a method called new virtual thread executor. In the newer builds that will come later, it will be slightly differently named. You can start a new virtual thread using thread.start-virtual-thread. You can create a builder that will allow you to configure things like a name and so on. You can get a factory of virtual threads that you can use as a usual thread factory. And then you have a runtime method that you can use to identify whether a thread is virtual or not. So in my examples, I will be using the new virtual thread executor, which is hidden in project Helidon. And I will be actually checking if a thread is virtual. So you will see that in the source code. So that's a very short introduction into Loom. Now let's have a look on project Helidon. We like to say it's a set of libraries for developing microservices. You can find us on helidon.io and on GitHub under Oracle and Project Helidon. The project is open source with Apache 2.0 license, and it's available on Maven Central. There are two main approaches how to write applications in Helidon. The first approach is based on the specification called microprofile, which is based on Jakarta CDI. It uses JAX-RS for HTTP. And this is like a proper small single application server that allows you to build declarative applications, a very similar way to what you would do in Jakarta EE. It's just as a single deployment. We have Loom support built in, and the limitation is that you need to use the current build, which is 74 or earlier. Because of the name change of the method, we will update our implementation to support the future builds of Loom as well. There are two configuration options that you can use. You can either use virtual threads, which will enable Loom support if you are running on a Loom JVM, and virtual enforced, which will only run on a Loom JVM. We also have a reactive libraries that allow you to build microservices, which are non-blocking reactive APIs. And obviously there is no Loom support in them because that's based on event loop and non-blocking operations. So right now, the way to utilize Loom is not that clear in this environment. You may still use, obviously, Loom executor services if you want to run something that's synchronous within a reactive environment. So the use case, let's finally get to the point why we want to use Loom and what does it bring us. So let's imagine a service that provides two endpoints. And this is a very usual enterprise kind of thing. You have a slow endpoint, something that does a blocking operation. So let's say that you have a query to a database that for whatever reason takes 2 seconds. And then you have another endpoint that is really fast, that just returns something from memory. And let's run it. And now if you have enough customers, and in our example, I obviously scaled it down to make, to really showcase the problem. So I run with 10 threads, and I have 2 clients running both with 10 threads. And one of them is hitting the slow endpoint, one of them is hitting the fast endpoint. And if you use the classical executor services, if 10 slow clients hit your endpoint, they will all wait until your database query or whatever you are doing finishes. If at the same time your fast endpoint hits that server, it has to wait because the threads are busy executing the previous requests. So what is the expectation here? The expectation is that the slow endpoint will run and eventually return, but the quick endpoint will time out because the threads are busy doing something else and we cannot return immediately. So how do we mitigate this problem? In the normal blocking implementation, and which is the history of the last 10, 15 years when we were doing stuff with application servers, you were tuning the blocking implementation. So you had to increase the number of threads, which eventually is not a good solution because you never know how many queries will come to the high performance application. So we've devised very clever ways of creating multiple thread pools, of creating work handlers that limited the number of requests coming to the long-running service. But all of them were really hard to tune and not always worked when you were under really heavy load. So eventually people came up with a reactive implementation. So you take your application, you rewrite it, and suddenly all of these problems are gone. Obviously we pay for it. The price that we pay is that you are in a reactive world and you have much more scaffolding in your code. And you cannot use blocking APIs. You need to devise ways how to get around it. So either you find databases which provide reactive APIs, or you still need to write some kind of wrappers around your reactive APIs using executor services. And back to the problem that we had in the beginning. With Project Loom, we finally have a solution that should work the same way that we used to work before. You just write your blocking APIs, but at the same time, these blocking APIs are no longer blocking the underlying threads. So your performance is as it should be without any need to change your code. And I think now it's a good time to actually switch to my IDE and show you how we can achieve that. So I have prepared 4 modules here, and I will start with the server. So I've created my application. It has a single JAX-RS resource. And this JAX-RS resource listens on the /loom endpoint and has 3 endpoints. I'm configuring the number of seconds that the slow endpoint will sleep because I want to, show something that's visible. So, it's not using, I'm not using 1 second, I'm using 5 seconds right now. We have the slow request. It's as simple as it gets. It just sleeps for the number of seconds that I defined and returns. In this case, I'm intentionally blocking the current thread because we need to show the problem that this whole presentation is about. We have the quick endpoint, it just returns. And then I have a thread endpoint that will return the number, the name of the thread and whether it is a virtual thread or not. So this is helpful to see that we have correctly configured our Loom environment and that we are really running on a virtual thread. So this is like a very standard Jakarta EE thing. The only difference here that you can see is the microprofile config property that we use, and of course the microprofile config properties file that defines the configuration of my server. So I'm running on port 8080. That's important because my clients are connecting to that. And you can see here that I configure my executor service. As I said before, I'm limiting the thread pool to 10 to make sure that we run out of threads when we overload it. And I have disabled the virtual threads by default. When we look on the POM file, we can see that this is a Helidon microprofile application. I'm just using the core libraries, which is JAX-RS and CDI. There is nothing special other than that. And I have a main class defined, which is outside of the project, of this project. So now that's my server. It's as easy as that. I have 2 startup commands here. I have a Loom shell script that will override the configuration property using a system property to switch to Loom. And I have a no Loom shell script that just says, oh, I want to use the usual executor service. So let's follow the path of usual development. I have created my server. I started without Loom because that would be my first thing that I did in a production environment. So my server is started and now the clients come. So let's say that my slow clients come first. And I've created this small tool that is monitoring the requests, and we can see that it's waiting for 5 seconds. And then after some time we get 10 successful responses back. And eventually this number increases. The problem is that now when I start my quick client, I'm expecting it to work, but for some reason I'm getting timeouts. And once in 50 seconds, it manages to push 10 requests through, but you can see the number of timeouts is increasing. And this is a service that does nothing. There is absolutely no need why this service should not work. So what do? In the previous work, I would go and say, okay, we need to rewrite this into a reactive environment. And let's have a look how much work that would be. So I need to change to my reactive framework. I am using YAML configuration and our web server. And I write service that is doing the same thing, but in the reactive world. There is one thing that I did here that's unusual in reactive world. I'm using a scheduled executor service for the sleeping, because obviously in reactive world, I cannot block the current thread. That's not allowed. So I'm using an executor service where I schedule that it should sleep for 5 seconds and then send a response. So it's exactly the same code. So exactly the same behavior as I had in the previous server. The only difference is that this is a non-blocking implementation. So we never block a thread. So how will this behave? Okay, I will show the main method as well. I'm creating a configuration, starting a server, and registering the reactive routing on that server. I've prepared it here. I have built my environment, and I just do java -jar. Of course, I need to stop my server before the blocking server before that, because otherwise it cannot open the socket. So I've started my reactive server now, and let's see what happens with the reactive implementation. So we can see the slow service works exactly the same way as before, because it's doing exactly the same thing. There is no need to change. But now when I start my quick service, we realize that there is a slight change. Suddenly, instead of doing 0 and timeouts, we get 40,000, 50,000 requests per second. And that's a really big difference. And the reason why this all works is that the threads are no longer blocked. So all the operating system threads can work on the non-blocking service. And this is the time when we could say that we have resolved the problem. But when you look on the reactive code, you realize that, okay, my code is really simple, but as soon as you start doing operations on the database, you realize that you are starting to work with reactive streams, and it's not simple, and the requirements on the developer are much higher, because as soon as you do a blocking operation, even accidentally, you can break the whole environment. So luckily, our friends at Loom decided that this is actually a very good way of programming. Like it's easy. You can just do return something, and then you can block on a thread. So why don't we just keep that in and use it? So let's go back to my application, to my server, and just start it with Loom. So let's see what happens. Okay, Loom. I will not wait now for this one, and I will just start a quick client. And you can see that it works similar to what we have seen in the reactive world. We will not see the same performance. We are, we still understand that we are working on a preview build of something that is still under development. But you can see that I'm getting 20,000 requests per second there without any change in the source code. Like my favorite part here is to switch between these two implementations. So I will just start with no Loom. You can see that we are getting a lot of errors right now. So I've switched to the no Loom implementation, and bam, there we go, our timeouts. We switch to Loom, and it runs. So, this is it. This is, if this works out and gets merged into one of the next releases of Java, we will be able to retain our blocking APIs, declarative ways of programming with synchronous operations, and at the same time have a non-blocking environment. So I will go back now to the code. I just want to show what I was doing in my clients. So The clients are the same, both of them. They just have a different configuration. So the URI is pointing to a different endpoint. And what I'm using here is our reactive web client, which is running in parallel in multiple threads. And it really just hits the endpoint, requests a string, and waits for it with a certain timeout. So it's a very simple client. Obviously, this is not a stress testing environment or anything, but I think it demonstrates very well how this works when switching to Loom. So single class, you just change the JVM to Loom and it works. I wanted to show the threads, so let me quickly do my other endpoint. So I will start my Loom server, and here I have a curl that requests the thread name. So we can see here that the name is unnamed and virtual is set to true. And if I started with no Loom, it will be using a Helidon executor service, and it's not a virtual thread. So everything works as expected. And the Java that we have used is the Loom build that you can download from the page I showed at the beginning of the presentation, and you can play with it right now. So maybe before I jump back to the presentation to do some of the summarization of what this is about, I will give you a place to ask about anything in the implementation that you would like to know. And if you don't have any questions, we can jump back to the conclusion of what Loom helps us with. Yeah, I can see in the chat that somebody is saying that's really impressive. Like, honestly, for me, because we are building the Helidon project and we have both the reactive and the blocking environment. This feels impressive as well, because building a reactive environment, reactive framework is really complicated, and using it is also complicated as well. And if we have this option in Java, it would simplify life of enterprise application developers, and it would probably change it a lot right now. Okay, so maybe I will just repeat one thing. I'm now using Helidon, and the version is 2.3.3. Which supports the current version of Loom builds. In the future, probably starting with 2.4.0, we will support the future versions of Loom. If you play with it yourself, if you use Helidon, it should work without any changes to your project. If you want to use Loom in your code, you will need to do a couple of things. So first, in your compiler, so if I go to my compiler, of course, I have it in the server. Just give me a second. So compiler, you need to enable preview. So there needs to be this argument, because if you use any of the APIs that are not part of the released version, the enable preview switch has to be enabled. Second, when you run your application, you need to enable preview as well. And then you can use the Loom API. So for example, here, this method is part of the experimental APIs. So I need to have this enabled, otherwise it wouldn't build. So there is a question, what would be suggested default Helidon flavor to go with once Project Loom comes to a stable release? I think that would be a very simple answer from me, definitely microprofile, because in general, writing blocking code is way simpler than anything else. It's very logical for us. It's like the natural thing to do for a developer is to write blocking code. Reactive code is, requires quite a lot of learning, and it's hard to do right. So definitely, once Loom is out, it would be great that we could just go with our blocking environment. The question which is not there in the log, but I asked it myself a few times, when will Loom be available? That question is hard to answer. It's definitely moving towards a release. I'm watching Project Loom since Java 16, and it's taking shape. It's the APIs are hardening, the features are being implemented and simplified in a way that's really easy to use. Which version of Java it will be in, that's still to be seen. We cannot, unfortunately, say a definitive answer for that. So let's go to the conclusion. Loom allows us to build declarative blocking applications, and this is something that we like to do. Or, I was watching the previous presentation. If you look at Project Helidon, if you look at other projects that are based as frameworks for microservices, we mostly start with the declarative blocking APIs. Most of these frameworks also support reactive environments and reactive programming, but the basic stuff is blocking declarative. So it's easy to write. Like, we want that. We want to write an application, deploy it, and not take care of a executor service and number of threads that we need to run. So in general, this is a great fit for common enterprise services. So I worked for 10 years in consulting, writing applications for WebLogic. And, if we had this at that time, like 80% of my work would not be needed, because 80% of my work was fixing performance, tuning thread pools, making sure that all of that works. Disclaimer here, we are running on preview builds, so obviously the performance that you see is not the final performance, and the guys are really interested in feedback. So this will change for the better. We want to build applications as fast as reactive, and the scaffolding is really hard. So that's what we want to achieve. I just realized one thing that I didn't put into the slides, and that's in reactive world, in Loom world, if you imagine that you have hundreds of thousands of virtual threads running in parallel, there will obviously be other problems. You will need to make sure that you do not consume too much resources in memory for your thread, because that would be really simple to run out. Connection pooling will need to be really handled well, and things like fault tolerance probably will need to be used more, because we cannot run 60,000 or 100,000 requests to a third-party service and just kill it because we are fast. So there will be other problems that we will need to look into, but these problems will be all because we are too fast, not because we are too slow. Okay, let me check the questions. Would Loom affect some concurrency patterns? Would we still need to use the same old semantics when dealing with concurrent data access, synchronized? So especially synchronized is something that cannot be used with Loom. So you can use all of the locking mechanisms in the Java util concurrent packages, and that's working absolutely fine with Loom. The problem with synchronized is that it's on a slightly different level, and it's actually synchronized on the thread level, not on the virtual thread level. So I think that's one area that is still being worked on to make sure that this works well in the Loom environment, but all the lock support and stuff is working fine. I think that concurrent hash map is exactly the tool that will work as expected, because all the locking mechanism is using locks in there. From what I have seen in the last status of Loom, I/O operations on sockets are already rebuilt to support Loom. So whenever you do any blocking operation on a socket, it will be working correctly with Loom. So it will block the Loom thread, not the operating system thread. HTTP, so that includes HTTP and all the things around sockets. The only thing that's still being worked on is I/O on the file system, because there is no natural non-blocking I/O in Java. if you look at the API right now, there are APIs that support non-blocking operations, but you still need some way to repeatedly request those operations. So that's something, again, that's still in progress to make sure that there is a good implementation for file system operations. But when it comes to talking with the outside world, with a database, with HTTP service, that's all already implemented. So if you download the build and try it, that should work without changes. Okay, I didn't say it at the beginning of the presentation. I said it to our moderators. This is not a very long presentation. I wanted to show the benefits of Loom and explain that this is already available for download as a preview. You can play around with it. And I would be really glad if there were any questions coming from you that I can answer. So maybe before I get any question, I forgot to say that one thing that's already implemented as well, and I have actually used it in my example, is obviously the sleep operations on thread, which are also now working on virtual threads and do not require an operating system thread. So this works as expected and doesn't block, as we have seen in the demo. Okay, so let me just point back to the pages where you can get the OpenJDK builds with Loom. Would thread priorities still apply to virtual ones? Okay, I do not know the exact answer to that questions. Obviously, thread priorities are slightly less important if you are running on virtual threads, because the threads on the operating system are utilized as much as possible. So this would make sense if you needed to schedule, like you would be overloaded on the virtual threads. And if I compare it to the reactive world, we do not have priorities in reactive world. You basically assign anybody who needs to work right now on the event loop. So my guess would be that that's what would happen with Loom as well. So as soon as there is a task to be executed on a virtual thread, it will be assigned to and pinned to an actual thread. So at which would you say it'd be better to switch to reactive programming instead of Loom? It's just a matter of performance only, or are there cases where Loom is not a good solution? Okay, I've actually talked about this with the with development of Loom, and their intention is that there will not be a performance difference between Loom and reactive programming. So my opinion is that there may be use cases where reactive programming is the solution, but I think that this will be like in very niche cases. And you need to have, a very specific use case that would say, or that would force you into reactive programming, even if Loom is available. I think in like 95% of all applications that are out there, it should be sufficient to switch to Loom rather than to switch to reactive programming. And honestly, this is very hard to guess. My first impression was, well, maybe if I need a huge number of parallel requests, it may be easier to use reactive. But then I played around with Loom, and it seems that that's just not the case. The simplicity is just winning over reactive. So we need to wait until the actual release, which will give us exact performance numbers. Right now, it seems that Loom should solve that problem. And honestly, I would actually be happy if reactive programming was not so prominent as it is right now in Java. Welcome. So if there's no other question, I would really thank you for listening. I hope that you will try Loom, and yeah, talk to you next time when I come back with something around Helidon. Thank you very much.